Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent announcement that has been made by the White House of United States of America, where it has directed the NASA, that is National Aeronautics Space Administration, to create a standard time for the moon similar to how it exists for the Earth. So, what is the reason behind this development or reason behind this decision, and what are its possible impact on the space missions not only from US but from other countries as well? Let us try to understand in more detail. So, to give you the context or background of this particular topic, to boost the lunar missions, that is the idea with which the Office of Science and Technology Policy, also referred as OSTP, working under the President's administration stationed in the White House, has directed the Space Agency of USA, that is NASA, to establish a coordinated lunar time, or as it would be called as LTC. It is very similar to the universal coordinated time that exists on the Earth, which is generally referred as the UTC, and the time at different places on the Earth, including India, is also calculated or measured with reference to the UTC, also sometimes referred as GMT. Now, the most important benefit that we will have with this kind of LTC development is that the cislunar operations, basically it means any kind of space related operations, space missions that is going on between the Earth and Moon. That is why we call it the cislunar. The space between the Moon and Earth is referred as cislunar. So, any kind of standardized cislunar operations with the universal time followed on Earth will then shift to the coordinated lunar time, that is a separate time for the Moon. Now, the reason behind this is very simple. If we try to understand, the size of Earth and Moon are humongously different from each other, and that is why, as per the special theory of relativity given by one of the most notable scientists, Albert Einstein, time passes differently depending on the mass of celestial object, and that is why time appears to pass more slowly where gravity is stronger, that means in this case Earth, like near celestial bodies. So, obviously the time on Earth passes at a slower rate as compared to the time at Moon, and as a result the length of the second on Earth is different to an observer under different gravitational conditions such as on the Moon, and similar logic we can then extend to the other celestial bodies of our solar system and even beyond. Now, what is the timeline given for development of LTC? Because it is not a very easy task, rather it is a very challenging task, need a lot of collaborative effort, not only from the space agencies of NASA, but space agency such as NASA, but also from other space agencies that are involved across the world, including India, Russia, China and European Space Agency. Now, the LTC will be the standard to measure the cislunar operations, the space activity between the Moon and Earth with the UTC. The deadline that has been given by the White House, the OSTP of White House Department, it has said that by the December 31st of 2026, NASA and its international partners should try to deliver a strategy that how LTC should be implemented. And in this regard, a National Cislunar Science and Technology Strategy has also been unveiled by the OSTP of the White House, where it has said or directed the NASA to engage with the 39 nations. In these 39 nations, you have India also, who has signed the Artemis Accord for the project that the USA is trying to basically launch in year 2026 itself, and to present its consideration of the LTC by December 31, 2024 as part of its Moon to Mars architecture concept review cycle. So, it has to present for the consideration of LTC by December 31, 2024, that is by the end of this year, while by December 31, 2026, it has to deliver a strategy that how we can implement the said timeline. Now, let us try to understand slightly in more detail about the coordinated lunar time. But before that, if you look at this diagram here, this is our Earth, and one day on Earth is basically equal to the time it takes for Earth to complete one rotation, and that comes out to be roughly about 24 hours. Now, that means one day is equal to 24 hours on Earth. However, if you talk about the Moon, the only natural satellite of the Earth, the Moon moves more quickly. by about 58 time moves more quickly on the moon, roughly by around 58.7 microseconds each day faster. And this is because the moon's weaker gravitational pull. The weaker the gravity, the faster the time runs. And again, to explain you, this is something that has been given as a theory which is referred as a special theory of relativity by Albert Einstein. He said two things. First, depending on the gravitational pull of any celestial object, time changes, the flow of time changes. If gravitational force is higher, time will run slower, and at the same time, length of an observer or length of any object also undergoes constriction. That means if gravitational force of any celestial body is higher, then the length of the observer will be shorter, time will run at a slower rate, and vice versa for a body having lower gravitational pull. And since the time taken by moon to complete one rotation as well as complete one revolution around the earth is about 29.5 earth days, one day on moon is equal to 29.5 days. So that is also very stark difference that we observe here. Now currently we talk about whatever moon missions that Soviet Union earlier, Russia, US or other countries such as China, India have sent, that follow the time of the country which the mission belongs to. And International Space Station, however, runs on the UTC. However, if we are able to develop a standardized time as proposed LTC for a space and the moon, which is not being followed right now, then again it will also become universal in nature, and all the space programs of all the different countries might be able to use the same time, and thus will avoid the confusion that happens right now. Now, if you look at the time on earth, how it is calculated. So, as we know, the standard time on earth is measured as per UTC, that is Universal Coordinate Time, and this is based on the 0-degree longitude that passes through the Greenwich city of London in United Kingdom. Now, on earth, the time is measured by different clocks. The most important of them is the atomic clocks, and atomic clocks are based on the vibration that happens on the of the atoms, and it is considered to be the time which is extremely accurate in nature, and that is why atomic clock are also considered as the most accurate clock on the earth. Now, other way of calculating time is by looking at the sun, which is generally called as solar time, and solar time is simply measured by measuring the rotation of earth on its axis relative to the sun. That means, as you know, the earth rotates 24 hours and it completes 360 degrees of rotation. So, taking that into consideration and also drawing the longitudes or dividing the earth into total 179 longitudes, 370 this basically 359 degree of longitudes, you can calculate time at different places. Now, in this regard, there is a concept called as TAI, that refers to International Atomic Time. Now, International Atomic Time is nothing but it is the weighted average of hundreds of atomic clocks that produces this TAI. So, now we have solar time and now we have the International Atomic Time, that is basically based on the atomic clocks. And the UTC that was suggested, as we discussed, in the 1960s somewhere, it was basically a way to accommodate the differences between time that you receive from atomic clock and the solar time that is more clearly visible or observable. And this difference between solar time and atomic time is basically accommodated by the UTC, and then with reference to UTC, the time at many other places or everywhere else on the earth can easily be calculated. So, that is how we measure time on the earth. Now, in this regard, we have a CTSP, that is Celestial Time Standardized Policy, that also has been something given by the OSTP of White House. The major reason behind this is to assign a time standard, not only the moon, because the moon is going to be the first celestial body where we will have a separate time, but to each celestial body as well as its surrounding space environment, first focusing on the lunar surface and then missions operating in this lunar this space that is going to be started, because we know that many countries, many space agencies are also planning in future to have a mission to the Mars as well and even to the beyond. So, in that context, this will be a beginning of a good step. So, in this regard, the Celestial Time Standardization Policy has given or outlined 4 features that some such standards must possess. The first, as you know, that everything we are measuring should have a certain reference to the time on earth, And that is why it says that any such kind of time with reference to any celestial bodies should be traceable to UTC, or we should be able to correlate it with the UTC, that is universal coordinated time on the earth. Second, it should have a scalability beyond the earth moon system, because that is just the beginning. That means you cannot develop a system today that only works for the earth moon system and then fails if you go beyond the moon, let us say for Mars. Third is the accuracy for precision navigation and science is something that we also have to take into consideration, especially when we are talking about a space, when you have traveled such a huge distance, millions and millions of kilometers. Even a small marginal error in time calculation cause a lot of errors in overall space programs. And last, resilience to loss of contact with earth. That means the time that is going on or time that is passing in any celestial bodies including earth should be having a kind of, we can say, independent status. That means even if it loses contact with earth, the time should be able to be calculated, it should be able to properly address it. Now again, to discuss finally that why we have a need of such universal coordinated time on moon also, which we will called as LTC, and the reason behind this is very simple. Recently there has been a plan to create a dedicated global satellite navigation system for the moon as well by year 2030. Now this GS or GNSS as it is called will be very similar to the GPS and other such systems such as NAVIC in case of India or IRNSS, GLONASS in case of Russia, and other such GPS system that exist for China as well, which works on the earth. So similar such system has to be developed on the moon also. Now these systems require to have a very accurate time, which should be with reference to the time as passes on the moon. Third is the moon missions that is being launched by various agencies will also need an official lunar time to communicate with earth based stations and also with each other. And last, many commercial operations that might be launched in the futures on the moon surface or lunar surface involving transactions and logistics will be more reliable if LTC is implemented rather than depending on the UTC. However, as we have discussed before, the implementation is not going to be very easy. There are several challenges that NASA and other space agencies has to face. The first such challenge is we have to take into consideration the effect of moon's gravitational pull. And as we know that the clock speed would also change depending on its position on the lunar surface because of the moon's rotation, which causes a gain of 56 microseconds over 24 hours. And this value is something that you have to take into consideration when you are basically setting up a clock for calculating time on the moon. Apart from that, there is also a debate that is going on, because as of now it looks like the entire operation or entire mechanism of developing LTC is largely being handled by US and its space agencies such as NASA. However, given the stake that many countries today are involved in lunar missions, should a single organization sit and maintain time on the moon? This is something that also has to be discussed. In other way, it cannot be a single agency or single country led mission. Rather, it should be a collaborative approach or collaborative mission. Third, in this regard, the building of consensus is also something that is going to have a problem. The reason behind this is very simple. Now we know that NASA or US has signed agreement with many countries including European Union, including India, which is called as Artemis Accord. So it is much more easier to have a consensus with such countries who are member of Artemis Accord. However, if we talk about other countries, especially Russia and China, who are considered as the biggest space rivals of United States of America, so they have not signed the Artemis Accord and they might pose hurdle in development of LTC or having collaboration with the US in this regard. So last, what we can say in the way forward, basically apart from US, several countries have lunar missions, and this is something that is clear also if you look at the past. Recently, China has announced that it will put its astronauts on the lunar surface by the end of year 2030. Japan also have increasingly shown its interest in exploring the celestial sphere of moon, and in January itself, Japan became the 5th country after US, Russia, China, India to land a spacecraft on the moon. India, if you talk about, it also has declared that it plans to land on moon in the year 2040 and is the only one as of now, the only country out of the 5 countries to land a spacecraft near the lunar south pole. So all this and all, obviously many countries are showing interest also, including countries such as UAE. We have many countries from European Union. So how far we are able to work together to formulate such a kind of time, because we already have done this in case of Earth UTC. So it should be not a very difficult task, but obviously it is going to be a challenging task. So we have to wait and see that how this entire collaborative effort or joint effort unfolds in the near future. That is all for this video. Thank you very much.